Okay, this video is about how to solve absolute value inequalities. That's when we don't have an equal sign, we have a less than, greater than, less than or equal to, or greater than or equal to symbol. There's two rules that we'll use, and how we decide which rule to use is whether we are given a greater than or equal to sign, or a less than or equal to sign. If we're given a greater than or equal to sign, we're going to use this rule, greater than, or greater than or equal to. You can go ahead and it's the same as if there's or equal to. So we would follow this rule right here for number 1 because we're given a greater than or equal to. We will follow this same rule right here for number 3 because we are also given a greater than. For number 2, we're given a less than. We're going to follow this rule right here for number 2. It would be the same if we were given a less than or equal to. It works the same way. All right, so for number 1, if we're given an absolute value expression is greater than or equal to some number, like we are in number 1, we're going to apply this rule right here. And this is where this value of A is greater than or equal to 0. That is what's going on here. Because we know the absolute value is a distance, it can either be 0 or it can be some positive value. So that's the restriction we have on A. Okay, for number 1, we have 8 minus 2x. The absolute value of 8 minus 2x is greater than or equal to 10. So I'm going to apply this rule. When I remove the absolute value signs, I'm going to write x is greater than or equal to A. So in this case, my x is 8 minus 2x. My A is 10, is greater than or equal to 10. Or x, 8 minus 2x, is less than or equal to the opposite of A, or the opposite of 10. And so I solve each of these inequalities for x. I'm going to subtract 8 from both sides, and I'll get negative 2x is greater than or equal to 2. Now to solve for x, I need to divide both sides by negative 2. Negative 2 divided by negative 2 is just x. But when you multiply or divide by a negative, it reverses the direction of this inequality. So we divided by a negative, that means this sign is going to turn into less than or equal to 2 divided by negative 2 is a negative 1. Over here, I'm going to subtract 8 from both sides. When I do that, I get negative 2x is less than or equal to negative 18. Now I'm going to divide both sides by negative 2 to solve for x. When I divide by a negative, it reverses the direction of my inequality. So I'll get x is greater than or equal to 9. And so here are my answers. X is less than or equal to negative 1, or x is greater than or equal to 9. On a number line, this is called a compound inequality, and it's joined by or. When something's joined by or, we keep any part that's highlighted. So right here, the values of x that are less than or equal to negative 1, if this is negative 1, it can equal negative 1 and anything less than. So all of this region right here. So I'm going to highlight that from negative 1 and left. Or x is greater than or equal to 9. So we could say 9 maybe is right here. The values of x that are greater than or equal to 9 look like that. This is the graph of this solution set. This is how we write it in interval notation. The values from negative infinity all the way up to negative 1 and including negative 1 unioned with the values from 9 to infinity. And we don't talk about any of this region because it's not part of our solution area. Okay, that was number 1. Let's go over here and look at number 3. The absolute value of x plus 4 is greater than 6. This has got a greater than sign, which means that we're going to again use this rule because it has a greater than rule. We remove the absolute value expression and write our two statements. X plus 4 is greater than 6, or x plus 4 is less than negative 6. And we solve each of these equations for x. We'll subtract 4 from both sides here. And we get x is greater than 2. Or we subtract 4 from both sides here, and we get x is less than negative 10. Here are our two answers. We keep, when they're joined by or, we keep any part of our number line that is highlighted. That's part of our solution set. X is greater than 2. This is 2. It's going to look like this. You do not include 2 because it doesn't have the or equal to in anything to the right. x is less than negative 10. Let's say this is negative 10. Do not include negative 10, but anything to the left that's less than you do. So this is the highlighted area for this one, parentheses and left, parentheses and right. So to write this in interval notation, this would be from negative infinity to negative 10. Don't include the negative 10, so we use parentheses. Unioned with from 2 to infinity. And again, we don't include the 2 because no or equal to, because this did not have an or equal to, and that's the solution to that one. Okay, for number 2, we're going to use the other rule because we have a less than. So when we have a less than or equal to, we will use this rule over here. So when we remove the absolute value sign, we set up this compound inequality like this. The opposite of A, or the opposite of 2, is less than x, without the absolute value symbols, 3x minus 2 is less than 2, which is just the A. Now we're going to solve this equation, this inequality for x. It's kind of like a three-sided equation, so we want to solve for x. Let's isolate the x term by adding 2 because of this minus 2. We're going to add 2 here, here, and here, all three places. Negative 2 plus 2 is a 0, is less than 3x plus 2 is just 3x, is less than 2 plus 2 is 4. To solve for x, I want to divide by 3 in the middle, on the right, and on the left. 0 divided by 3 is 0, is less than x, is less than 4/3, and this is my solution. If I was going to graph this, do you see how x is between 0 and 4/3? We are going to highlight the region between 0 and 4/3. Just like that. And to write it in interval notation, you just write down the part that you highlighted, parentheses, 0, 4/3, close parentheses. So if this had had an or equal to, everything would be exactly the same except for these would be brackets. That's the only difference that we would see.